Hello everyone and welcome to another Focus Chat. The topic of this Focus Chat is domain-driven design. And in order to talk about domain-driven design, I invited somebody who has a lot more experience in this than I do. And hopefully we can learn a lot more. He is the founder of the DDD Europe conference, founder of Arling, a boutique consultancy that advises organizations on designing software for complex environments. He has a series of articles published on domain-driven design in collaboration also with Rebecca Worsbrook. We reviewed one of them. Welcome, Mathias Verraes.
Thank you for having me, Alexander.
I've been looking forward to this because I'm looking forward to learning more about how domain-driven design is applied in practice. And I think you have a lot of experience with this. But before we start, I think it's interesting to learn more about your background and your origin story with software development. How did you get into software development?
Well, I was actually a musician first. I studied at the Royal Conservatory in Ghent in Belgium, and I was mostly doing music for films and documentaries and commercials and things like that, and all kinds of things really. Like I conducted a pop choir, things like that. And but I started making websites for the projects I was involved with, and I did some programming as a child. And that sort of led to to other things. I started using open source software and figuring out how to make changes to it, and then people started inviting me. So that's sort of how I rolled into software. And then for a long time I felt like I didn't really understand. I could understand programming, but I didn't understand how people made large complex systems, right? I could understand a simple website or a simple web application, but so I was really looking for information on that, and I started reading everything I could get my hands on. So obviously like Martin Fowler and Michael Feathers and authors like this, Rebecca Worsbrook. And then I found out about and I was already like I was working at a small startup and doing a lot of modeling together with the founder, like trying to understand how to build, how to solve this problem. And we were doing, I would call it modeling. It was very basic and elementary, but we were trying to draw the structure of what we were doing before building it. And I felt like, okay, this is probably how people do it. And then when I discovered Eric Evans' book, Domain-Driven Design, that was the eye opener for me. That sort of showed me that, okay, there are actually people thinking about, these kind of problems at at different scales, etc. So that was really the starting point for me to get into this stuff. It's one of those. I think it's one of the very few books in software that tries to cover everything from the micro, right, code and patterns in code to high level, systems and bounded context and models, to even higher level, the integration between clusters of bounded context, large scale structures, responsibility layers, these sort of ideas. So that was extremely fascinating to me. I think it's still one of the only books who's really attempting that right now.
Yeah, so just to since we haven't met before, it's we just kind of discussed on Twitter and had this. I have come from. I've learned multiple programming languages. I also went through programming university, and I've done a bit of modeling, but then I got dissuaded out of doing a lot of modeling by the XP bunch, about doing emergent design using test-driven development. Although I am of the opinion that you still need architecture, so I never imagined that you can emerge architecture. That's a completely different topic.
Yeah, well, you have architecture, whether you think you need it or not, you have it, right? And and the pendulum swings, right? There's been this movement of big design up front. Let's do a lot of upfront design. Let's hammer it all down, and then it's only building the system. At least that's sort of the you know that end of the spectrum. And I think that belief originated in the fact that changing software wasn't as obvious as it is now, right? Now you can just change a line. It's a second later, it's on GitHub. A minute later, you can have it deployed and running. We came a long way to be able to do that, right? So there's that. There's also the fact that, of course, programmers are expensive, and the whole idea was, I think, right? I wasn't there, but to create sort of intermediate steps as ways of getting more certainty of guaranteeing that you would end up somewhere good. So we had analysts in between, and we had sort of a very manufacturing mindset about software. It's stages in a manufacturing process, and there's quality control at the end, and there's production and these kind of phases. And then, of course, the whole agile movement, which was well, I already mentioned Martin Fowler. Eric Evans was part of that. He worked with Martin Fowler in the years before the Agile Manifesto was written. He worked with Ken Beck, so he's very much in that agile mindset. But I think people took it to extreme, right? It's not that they said no big design up front, which I fully agree with, but then people interpret that and they sort of make that point more extreme, as it is like opinions are mimetic, right? Opinions are copied and transformed, and people go more and more extreme when they do that. So what you end up with is that there's indeed a lot of people who believe there should be no design up front, that modeling is a bad thing, and they get confirmation for that, because in the short term they're absolutely right. It's a waste of time, right? Doing design, if you're making something small with a very small group of people, you can understand the whole system, you can see how it works, you've built it, right? You can make changes fast. So the feedback loop of your design choices, whether you always have design choices, whether you are aware of it or not, right? So, but the feedback loop of whether your choices are good is very slow compared to the speed of delivering, which can be instant almost. So I think that sort of confirmed this idea that design is maybe not a necessity. And then there's of course people who switch from startup to startup, so they never actually get that feedback loop at all, or they move from within the same company, right? They start maybe as an engineer, but they move to different roles. So then as well, they don't really have the feedback loop, the day-to-day sort of consequences of the design choices. And so we end up with huge monoliths or distributed monoliths and technical depth and legacy and systems that nobody really understands. And most of the time making changes in those systems is spent reading and reverse engineering and trying to figure out what was the system doing, why was it doing that, does it have to do that, or is that a leftover of something? Is this code even actually still being used, or is this dead code? And then trying to make changes, and then trying to make sure that your change didn't break things. That's a very expensive process. But that feedback loop comes later. And then when you're in that situation, at every point making a new change, it's always cheaper to make the change in the system than to first try to improve the system to make more sense and to be better structured, etc., and then making the change. But every change makes it worse. So you have this self-reinforcing feedback loop now where the system gets worse and the cost of fixing it becomes higher. So that's a major crisis in software, right? But we don't realize it's a crisis because everything we do is like that, almost.
Yeah, and I agree with you. I mean, I understand the need for modeling in certain contexts. So if
Yeah.
I'm going and working with a large bank, or if I'm going and working a large financial institution, or I don't know,
Yeah.
telecommunication company and so on, then we need to do some modeling because most of the products there are built by multiple teams who need to
Yeah.
somehow be able to structure and to think in a similar way. And often these projects are very time bound, so you need to
Yes.
develop them within a time frame. It's not like you can take as much time you want and so on.
Yeah.
Uh, with
Yeah.
this
Go ahead.
being
Sorry.
said, there's still a tendency going to domain-driven design. There, I have seen a tendency of using it as a way to do big design upfront.
Yeah, sure. People will always, use things in different ways or abuse it or misinterpret it. Especially something so domain-driven design is intended for complex systems or for complex domains. Um, and then it's not a very obvious thing as a consequence, right? It's not an easy book to read. It's covering a lot of ground. It's also not really written in the most sort of entertaining light reading style. Um, but it's trying to deal with complexity, right? So it's not it's by nature it's not going to be easy. Anything that deals with complexity and that is easy, there's something wrong, right? Because if it was easy, it wouldn't be complex. Complex is really just our, when we say something is complex, we're really saying our relationship to that problem, right? It is complex for us because it has all these, interacting properties that, and processes and there's sort of no linear path through it, right? Depending on which sort of definition of complexity you use, of course. But something where when you make an intervention in a complex thing, the outcomes are not predictable because the outcomes create other outcomes, spreading through the system. So an intervention might give you an entirely different outcome than what you intended. That's another sort of definition of complexity. Um, but so people are indeed going to read that and say, oh, we have to make huge models up front and then build them, even though the book is really not saying that. But because the book is not an easy read and it's dealing with complexity and it's not, light reading, people haven't actually read it. It's a true classic, right? The book that everybody has on the shelf, but that most people haven't finished. Um, so that's a bit of a problem. Of course, now there are many more books and books that sort of find ways of explaining it, maybe in a more approachable way or explain different aspects of it. But it's never intended as a big design upfront thing. There's a lot of, there's presentations and papers by Eric Evans where he explains this. He calls it the modeling whirlpool. It's very much sort of an agile idea of find examples, have conversations with domain experts and users, figure out sort of scenarios and examples of what they're doing. Look for the awkward situations or the edge cases, etc., because they give you insight in the problem, and try to sketch a simple model. And I use the word sketch very deliberately here, right? It's draw something, right? Don't make a very detailed with everything pixel perfect and straight lines, and just jot something down and then try to make a proof of concept for that. And a proof of concept here is also the very lightest way of doing that, right? So don't build a full app, don't build a user interface, just write some tests, write some implementation that fits within that model that is that shows this model in action, and then maybe figure out if that go try it, right? Go show it to the domain experts maybe. They might not be able to read code, but if you try to write really in the language of that domain, in the language that they are using, and there's no technical language in that code in the sense that it's not dealing with databases, it's just sort of a proof of concept for the model itself and some tests, it should be quite readable. I'm not saying that you have to show your code to domain experts to do DDD, but having this underlying mindset of, can I make it readable to domain expert? Would they understand what I'm doing here? And all of that is a very small process, right? That's maybe a day or 2 days or something, but you get a very fast feedback loop now on your model and how it works and if it fits that problem, if it fits the mental model of that person, of that stakeholder. That's a very much agile and iterative approach. I'd say that's more iterative than most agile as practiced, which is usually incremental as opposed to iterative, right? They just add stuff. Here you go back and you say, well, this model was nice, but it's a bit too bloated. Let's take it down a notch. Maybe we didn't need all these types. Maybe we thought we did, but now that we actually implemented this proof of concept, it turns out that, well, we can solve it more simply. Or we need to find a different model, or we need to restructure this bit, or actually this stuff doesn't really belong together. Let's separate it, right? So it's really originated in that mindset of fast iteration, but it's iteration on the model, not just on the code, not just on the product, but on the model itself that underlies the whole thing.
Yeah, and I think that the challenge here is because if you look naively at domain-driven design, it's fundamentally domain modeling plus a set of patterns. And these are the things that are easy to kind of grasp. And you need to do some repositories, some aggregates, some whatever, and then build some domain, figure out some names from your domain and how they fit together in a bounded context. Yeah. But then I think the iterative part is kind of missing from the general understanding. Also doubled by the fact that we tend to spread information like folklore in software. So absolutely. You said about people not reading the book. Yes, because most people learn about these things from other people. So it kind of becomes folklore in time.
Absolutely, yes.
So,
and then things like the patterns. Oh, sorry, go ahead.
What would you add to explain domain-driven design to software developers?
Yeah. Well, it is. You're absolutely right that modeling is at the heart of it, right? And even before that, starting, I would say it's a design discipline. It's not a methodology. A methodology is a specific set of activities that you do, right? Domain-driven design isn't really prescriptive in that sense. It's more of a set of principles. And like any discipline, the more you practice it, the more you make use of this, the more of the benefits you're going to have, right? And so, the benefits we're looking for is being able to build and maintain software for complex domains and keep it sustainable, have it sustainable, right? Still understand it in 10 years' time when we have grown to 1,000 engineers and still be able to manage and evolve that system. That's the long-term goal, right? And then how do we achieve that? That's those principles. So within that discipline, I should mention there are methods, right? And these methods keep evolving and changing. Maybe as a comparison, test-driven design, I would say, is a method, right? It says do these steps in this order. If you do all of them, you're doing test-driven design, right? So red-green refactor, basically. Write a failing test, implement it, refactor it if you need to, write the next test, and do this at a very small scale and repeat it. That's a method. Within domain-driven design, there are many methods. Some of them have sort of, maybe gone out of fashion. Some of them have grown. The patterns you mentioned, aggregates, repositories, etc., I would say that's sort of a method, right? Here's a set of patterns, building blocks that you can use to implement your model in code, right? These will help you. As with all patterns, right? We have tried to implement models in code, and by doing this many times, we have seen that some of these things are repeating. So we describe them as patterns. We give them a name. We can start using them. There's nothing about domain-driven design that prescribes that you have to use those patterns or that these are the only patterns. Quite the opposite. But they are. You could say that's a method. Um, there's other methods. There's event storming, which is a very visual, collaborative modeling style where you use post-its or virtual post-its to explore to visualize the processes in your business. Like what's a shipping process like? What's a credit decisioning process in a bank like? All the steps and all the interactions, etc. You visualize that. Event storming is a method that helps you that fits within this set of principles of DDD. And so, what are these principles? Well, of course, the name suggests your design should be driven by the domain, right? The problem space, the world of the business. So you need to. What we believe in the domain-driven design community, I could say it like that, or a premise, is that great software is a consequence, is built by people who understand the domain well enough, right? You don't have to be an expert as a software engineer. That wouldn't be possible for some domains. But you need to understand enough of it that you can design your software that way. And your software should be designed to mimic or reflect that domain. How do we do that? Well, we need to go talk to the domain experts. We need to go meet with them, right? Not just here's some requirements that we throw over the wall. We want to go see what they do and how they do it. I say talk, but it could be talking and visualizing and any kind of. But we're really looking, and that's something that domain-driven design introduced back in 2003 that maybe some people were doing, but nobody was describing it that way, as creating that entire link from engineering to product and business and domain experts and share the same understanding, share the same language, right? So ubiquitous language is a big thing in domain-driven design. Again, it's not invented, right? It's a pattern that is described in domain-driven design. But it's by doing so, by describing that as a pattern, it's drawing attention on it, right? And it's not it's not just copying language that people are using, right? So you talk to a domain expert, they will have a domain language, but this language is organic, it's messy, it's ambiguous, right? Language is social, right? Language evolves within a social group to solve the needs of its users, right? It's not that they sit down and say, let's design a language so we can talk to each other. It's just, you're working, you're doing things, you're coming up with a word for it. Maybe you're using a word that was already had already another meaning. Maybe you use a word with multiple meanings, or maybe you think that two words have the same meaning, but actually there's a subtle difference, right? So this language is very messy. And computers, of course, don't really like mess, right? They need precision, right? Even a semicolon in the wrong place, it will crash your software, or at least your compiler. So we need to formalize that language. We need to find ways of agreeing on, okay, this is what this means. This is what this means. This is how these terms relate, right? That's very much a design job. It's taking that domain language and turning it into what we call a ubiquitous language, a language that is shared, that is designed, that is shared and agreed upon by all the stakeholders, so that everybody can speak that same language, right? So in a ubiquitous language is almost an artificial language, but it's very much based on this language that they're already speaking, right? And that will facilitate communication. That will make sure the point is, of course, that we use this language in the documentation, in the user interface, in the code, in the tests, everywhere, right? Or as much as possible. And now, because everybody has that same language, we can start looking at any system, at an old system, at a large system, and we can always, if we understand that language, we can understand the system, we can understand what it's doing, as opposed to what programmers do is make up names, right? And we've already used that word for something else. Let's just come up with a different word for it. That's not really the right mindset there. And of course, the domain experts are not designing the language. It's not their job. They're not designers. We are the ones who will have to do that work, but involve them and have them agree upon it. So that's a very big thing in domain-driven design, right? If you do that, you're already like 50% closer, I would say. And then what you're doing is that language, of course, forms a language and a model are almost, they're hard to separate. They're two separate things, but they're still you can't have one without the other. Your model is the how all of this is structured, how it fits together, and you're trying to draw that. You're trying to design it. You're trying to decide what is inside, what is outside. It could be there's many kind of models, right? We tend to think because of the major influence of object-oriented design that a model is things, entities with relations between them, and then maybe some behaviors inside, right? But that's just one way of modeling software. I already mentioned event storming, which is processes. It's events happening over time, commands that impact those events, rules that influence these events or influences branches in the process, processes that influence each other. You can make models like that. And of course, there's many more things. You can do journey maps or example mapping, or all of these are domain storytelling. All of these are ways of modeling that they're expressions of the same problem space of the same domain, but they focus on different things. They highlight different things. They use different building blocks. So this modeling is very important because it's same as with design, right? You're always modeling. When I explain this to you, what is happening here is I have a model of domain-driven design in my head. You have maybe some model in your head. I'm trying to synchronize my model to your head, right? That's what this conversation is. But this creates a third model, which is our conversational model, right? It's not everything that is in my head is literally coming out now in the shape of a finished model, right? It's bits of information. With domain-driven design, we're saying, yeah, this happens all the time. Let's actually make that explicit. Let's draw those models. Let's document them. Let's use them, and again, use them everywhere, so that the way it's in the head of a domain expert, the way it's in the head of a user or a tester or a documenter, is the same as what the code looks like, right? That we really share these models. If you're doing that, you're like 90% the way there. That will we know this because we have been doing this for a long time. We see that this code is in fact more evolvable, right? Things say what they are there. We always say make the implicit explicit, right? So there's no sort of hidden complexity. It may look more complex than code that wasn't modeled at first, but the complexity is not hiding. The complexity is right there on the surface. The ideal code is equally complex as the domain it's modeling, with maybe abstractions and generalizations and things like that to make it more manageable. But it's not hiding things. For example, if you have two microservices that may look like two simpler systems, or let's say 10 microservices, it looks like a simpler system than the monolith. But if all your connections, if you now have like 50 connections between them, you actually have made a more complex system. That's the sort of thing we worry about in domain-driven design, right? Is this model at the right level of complexity? Is it showing the essential complexity of that problem? Is it not adding too much accidental complexity? Is it not mixing? Like we try to, when we write code, we try to avoid to mix domain-focused code, so the things that express this model, business processes, etc., business entities, that there's a layer of code that only talks about these business concepts, and the layer that deals, or the layers that deal with technical things like databases and messaging and logging and all that stuff is sort of kept outside of that pure domain model code. And what we have noticed is that this actually works very well. There's patterns like hexagonal architecture, ports and adapters that embody that same idea, right? There's this pure core at the heart, and there's sort of layers of interacting with the outside world around that. And we see that you can go back to that code, and it works the same way that models work in science. So what is a model in science? It's an interpretation. It's always an abstraction, right? We have it's a subset of reality. It's an abstraction of reality, but it's helping us to make predictions about that reality, right? I can predict that if I drop my phone, it will fall to the floor because I have a simple model of gravity. This model isn't good enough to predict, my model of gravity isn't good enough to predict, string theory or quantum mechanics or anything like that. In my context, it's a good enough model. I know that something will drop to the floor if I let go of it. But that model is good enough because it gives me predictions that are useful to me. How does this work in software? I want to be able to look at a piece of code. I have some requirements. I can make that change in the code, and I know what the impact of that change will be. Right? I know that this will affect these other things. Tests help for that, right? Because tests are sort of the empiric way of doing that. If I make that change and I think, well, this change shouldn't break anything else, and half my tests break, that gives me, an empiric observation that I was wrong. But we also need this at the level of really understanding it, because tests are limited, right? They're only as good as what you actually wrote. But you also need to understand how it works, what that change will do, or what that addition will do, how it will fit in with everything else. For example, very often a business rule isn't very complex. What makes it complex is the combination of many business rules that all sort of overlap and impact but what if this thing happens and that thing has already happened, but this thing is not finished, and that's where the real complexity is. If we have a good model for that, if we have visualizations, if we share a language, that becomes predictable. Predictability makes us very fast, and that doesn't happen again, when you start building a completely new system, you don't get that benefit yet, but over time you get that benefit where changes remain equally cheap over time. Why do they become expensive? Because, as I said, right, you have to go dig in the code and do reverse engineering and do a long quality assurance process to make sure that you didn't break anything and do a beta release. And I'm not saying you shouldn't do all these things, but if you understand what the impact of your change will do, if you can make accurate predictions, then your model is working for you, right? It's giving you those benefits. So it's worth investing in it because it allows us to remain fast and flexible and evolvable over the long term.
So that's fascinating to me, what you are saying, because the way you mentioned before that the industry still understands software development as a manufacturing-like process, and we very slowly move away from that. And I think, to me, the best metaphor that I could find for software development is that it's a knowledge refinery. Basically, we get very fuzzy knowledge as an input, yes. And then we keep refining it until we get it to a very precise level where a computer can actually run it. Because in the end, code is knowledge. It's all the knowledge that we have about that system needs to be in the code, otherwise it won't do what it's supposed to do.
Yeah.
And the reason I find this fascinating is because you are talking about models in science and the empirical method, and it's kind of the same thing, right? The scientific method and the empirical methods are ways to refine knowledge and to improve the models until they predict better.
Yeah, I will agree with you most of it. It is right. It's software is a knowledge refinery process. I like the name here. It is, what ends up in the software is what we understand about the problem we're solving, right? It doesn't matter what your client wants. It doesn't matter what the analyst wrote down in the requirements document. It's what the engineers understand that ends up being written in the software. That's absolutely true. But it's also design. So there is an aspect to that you cannot capture by simply refining knowledge. And this is what you reviewed our blog post, right, about design and reality. That's sort of the point we're trying to make there, is that there are sometimes things that are not they're not just there to be grabbed and implemented in code. Sometimes you have to make creative inventions, or at least creative discoveries. Um, so it is a bit more than just knowledge refining. It's a lot of it, right? It's like 90% of it, or maybe 99% of it, and then there's the bit where there is actual sort of deep design, and where you need to think of novel solutions and creative ways of solving it, something, and seeing something that isn't there yet, or that is so implicit that it takes an act of being open to finding it and to capturing it, and trying it and probing for it, that you need. There is, and so this combination of knowledge, refinery, and design, I think we have a word for it, and that's actually engineering, in the sense of, so Billy von Kohn has written a book called The Definition of the Method, which is the same. We have a definition for the scientific method, but he said, well, we don't have a definition for the engineering method, and then he works through how to figure that out, and that was like one of his major works. And he says engineering. I'm not sure if I can quote it accurately, but the engineering method is making changes to have an impact on your world in a poorly understood situation, with limited resources. You never have infinite resources, and you're using heuristics to do that. So a heuristic is in that definition. A heuristic is something that doesn't give you any guarantees, but it gives you possibly it can give you progress towards a solution, or it could even be progress to asking the right questions, right? But in the end, everything is heuristic in engineering. All our design principles that we have in software, they aren't really principles, they are heuristics. They principles are more, they try to be universal, but often they're not actually universal. They're just very common, or they were universal in the context where they were defined, but they're not universal. But this combination of things is engineering. There's a design aspect, there's a creativity aspect to it, there's a knowledge crunching, capturing and refining, and figuring out these things, capturing that, turning that into actual working systems. We have to be technologists and somewhat domain experts and modelers and all of that. And especially given the sort of, I think what's unique about software engineering compared to all other forms is that with software, we can acquire complexity much faster at much larger scale than we ever could before. When you build a bridge, you can make a simple bridge or a complex bridge, but there's strong limits on the complexity of that thing because it needs to not crash, right? There's a physical reality. There's limitations to how much you can modify it afterwards. That's all very, very constraining. Or paper processes before computers were quite simple, because if you want to share information from one place to another, you had to send somebody by horse. That's how they did bank transactions, right? So you cannot also, what we now have, because we can share information across the world at light speed, we want to actually do that. We want to find, like, everybody has built integrations between this and this and this system and data from there, and rewrite it and combine it and join it and do analysis on it, etc. Because we can, but the demands are much higher, because we can. So we have this very extreme new way of engineering, and we're in the Stone Age of doing that. We haven't figured it out yet, I would say.
Yeah, and I think one of the reasons for that is we have this freedom of inventing our own words and concepts, and with little limitation. Okay, we have some limitation because it needs to run on a computer, so you are limited by what a computer can understand, by the programming language and so on. But in the end, a lot of things about software is actually about this semantics, about this semantic network of things that you write there, and whether you deploy them as objects or microservices or functions, it's in the end it's a matter of just figuring these things out. And
absolutely, and this is something that domain-driven design, because we're still trying to describe what it is, right? Because it is a big discipline. So this is one of those things that it made very explicit. It said it's not just a software system is not just technical, of course. It has this language from the domain that we try to get. It has models. We need to be explicit about it and collaborate on that. And then it says, well, we cannot have a language and model that is useful for everything. We cannot have, for a large complex environment, right? A bank, for example, we cannot have a single language and model. It would be too complex. It would be massive. It would be extremely bloated. Nobody would understand it. That's a limitation of the human brain, not of the computers. Computers are fine with monoliths. It's we who are not. And then how do you deal with that? Well, there is, of course, a long tradition of modularization in software, going back to David Parnas in the 70s, the paper. But so far, a lot of the discussion has been very technical on separating systems along technical boundaries. Domain-driven design says, well, you have context, right? A language never or a term never exists in isolation. A word always has meaning because of the meanings of the surrounding words. That's the whole semantics thing, right? If I say I placed an order for this product, right? How do you interpret this? Well, you think, okay, this is probably an e-commerce thing, or at least a retail thing, or some way of doing business where people can order products. If I say the word product, it could mean a mathematical product. If I say the word order, that could mean a military order, right? If I say the word place, that could be a location somewhere. But the combination of these three words, I place an order for this product, creates a context where these words acquire meaning from each other, right? In domain-driven design, we're accepting sort of that complexity, that these words, these terms have meaning within their specific context and maybe different meanings in other contexts. And we're taking that idea all the way. And we're saying, well, even in an e-commerce system, right? A product in the product catalog is something that we can, something that we can sell that has maybe some pictures, price, description, customer reviews. That's a product. When we want to order that product, and we go to the warehouse to do order picking, then product means something slightly different, right? We don't care about the price in the warehouse. We care about the location and the dimensions maybe, and how many we have of it. We think of them as in bulk, right? We have hundreds of these that are interchangeable. They're all the same product. And then when it goes to shipping, they don't care about that stuff. They have a different model and a different meaning for product. It's not entirely different, right? There is a relation here. But when you're shipping a product, you care not about the dimensions of the product itself, but you care about the dimensions of the box it comes in. You care if maybe this is very heavy, we need 2 people to carry this. I don't know, I'm just saying things. Right? And you care about where it needs to go, of course, and all of these things. But we're sort of misled by the name, right? We think, oh, it's product, so it all needs to be the same product. And we say, oh, don't repeat yourself, right? Try. We need one single source of truth for product. So now our model is very complex, really. Well, it's not that bad in this example, but now product has a lot of sort of responsibilities and meanings across these different stages of its life cycle. In domain-driven design, we're saying, well, no, let's not try to unify that. Let's not couple these things. Let's say a product exists in this context, in the product catalog. It has these meanings, it has these properties, it has these behaviors, it has these processes that it's involved with. And then there's maybe a transfer. That transfer to the shipping context is or to the warehouse is a translation almost, right? We translate. We don't need to tell them everything. We tell them the minimal information they need. This is API design as well, right? But we're looking at this from the point of view of language and model. We're saying, well, from now on, we're saying in the context of the warehouse, a product is defined like this. These are the processes, these are the behaviors, these are the business rules, etc. And we separate these models. We have two models now, or three with the shipping involved. And we're in domain-driven design. We say that should be our first or main way of separating these things. First, look at how the models are separated in the language, and then build systems according to those lines. In practice, that doesn't even always work because maybe we have, some legacy system. Maybe we acquired another company that also does part of the shipping and that has some features we need for ordering, but it doesn't deal with service as well. So this kind of thing, and then we might change and migrate some of it and all of that. I don't know why my camera is acting up. Sorry about that. But we're thinking of these different models and languages as first class, as elements in our design. We will start using the name. We will give them names. This is the order context or the shipping context, and we will think about what things belong where based on that language. So it's sort of a higher level of thinking about software. It's not pure coding, although it's effect coding. It's not what we typically call architecture, although it affects architecture. It's another first class thing in there, I would say. And that's also an innovation that domain-driven design has brought.
Yeah, and to me, I equate the bounded context and everything that you describe here, I equate it with something that happens in language as well. So
Yes.
in any language, if you take English language, for example, you have the grammar, you have the words, you have the semantics, you have all these things. But then you also have jargons. So people who are very specialized in a domain, they will use specific words in specific context. And okay, it's not as precise as what we need in software, but it's fundamentally the same idea. So the way I'm looking at it is like in domain-driven design, we are creating, in this bounded context, we are basically reflecting the jargons or creating a specific jargon for that specific part of the product.
Yes. And it is the difference is, of course, that when people are using it, it's usually a natural language, an organic language, messy, ambiguous, etc., social. And as designers, we formalize that into an unnatural language, but a designed language. And that's why I'm saying it's a design activity. And of course it needs, and I say formal, but the level of formality really depends on your situation again. If you're a startup doing, I don't know, some social media product, for example, your needs for a formalized language are much less, right? If you sort of, yell across to the other table, hey, what should we call this? Yeah, that makes sense, right? Here, you have a lot of freedom in inventing it. If you're doing this for some, I don't know, I've worked on modeling with a company that does they design software for the drug fluid pumps that they use in hospitals, to administer chemotherapy, etc., to patients. They have, of course, a much stronger need for a very precise, well-documented language. In some environments, you need RFCs, etc. So that's very much depending on your situation. But it's still, at any point, the moment you start debating and agreeing on this language, you're doing something more than what people do with an organic language. And of course, maybe I should also add, sometimes there is actually already a very well designed language in that domain. If you're building an accounting app today, you wouldn't reinvent a language for accounting. That language is hundreds of years old, some of it, right? It's some of it is defined by law. So you're using this existing published language as your domain language. You're not doing a lot of design on it, or as little as possible, but you're still doing a deliberate adoption of that language.
All right, so we talked a bit about ubiquitous language, and it's definitely one of the key elements, I think, of domain-driven design. So,
yeah,
just briefly, how do you go around identifying and managing this ubiquitous language? Because you also learn more as you move along, right?
yeah,
And sometimes you need to change your modeling, your
yeah,
existing code, your based on the new understanding. So how does this happen in
yeah.
practice?
Well, many ways, of course. Well, as you suggest, right? A change in the domain is a change in the language, is a change in the model. Um, so in any case, that sort of, we call it refactoring towards deeper insight. It's not just code refactoring, it's model refactoring, right? If we learn something new, if we get new insight, actually put in the work to make the model, the code, the documentation, etc., back, in sync with that new understanding. That's very much the first thing, right? If you allow this to sort of diverge, you will end up back where we started, right? With a system that doesn't look like how we understand it anymore. So that's key, right? It's this desire to keep these things in sync. And then an important part, I think, that is maybe under discussed is this sort of observing. You need to be in a mindset where you're always observing and listening for this language. If people are describing something and they mention some word, instead of just sort of letting that pass by, you should think, wait a minute, is that word, is that important? Is that relevant? Should we use that? Are they using this word for something else that I haven't heard yet, right? And you talk about it and say, well, what do you mean by that specifically? Or you can ask the question like, yeah, we talked about this, and then we had this edge case, and now you said, oh, we have a process of, I don't know, let's say giving the money back when it turns out that they overpaid us, or if there's a change in the delivery. And what do you call that process? Oh, we call it refunds, or we call it reimbursements, or something like that. And then you start digging for that, like how would you use that in a sentence, right? Because the language is not just words, right? It's not just things. It's sentences, it's grammar, it's idioms, right? It's perfectly possible to use words from that language in a completely grammatically correct English sentence and still end up saying something that no domain expert would ever say. So you dig for that and you look for that nuance and you observe when people use words. I think that's sort of a skill that you need to develop that will give you a lot of insight in the domain, and that will sort of let things emerge that you can then use to make better models that are more explicit, right? Instead of just having some function that pays back money, you can say, oh, this is the refund thing, right? Or the reimbursing process, or whatever you call it. Even the business rules, right? That people say, oh, but we, if customers buy 5 of these, they get some discount for something else. What do you call this? Oh, this is the loyalty discount, right? Instead of just saying it's an if clause somewhere, can we name that rule? Can we say, oh, this is the loyalty discount for high spenders or something? Give that a name. Name your object that way. Put an object in between. Delegate the decision that is in that if statement. Delegate it to that object or to that function or whatever. Give it that name, and now your code, instead of an if and some numbers, it says apply this business rule with this name, right? So the business rules become first class. So you're constantly looking for that language, embedding it in your model, in your code, in your other artifacts. And then, of course, when something changes, Somebody says, "Yeah, remember how we had that rule about discounts? Um, we're giving too many discounts. We want to have this other limitation." Now you can look at the code, you see exactly where that rule sits, and you can say, "Oh, let's combine this with this other rule, right? Or let's make, I don't know, maybe you need to change the code or add something or remove something or." And when you keep doing that, embedding that language and model into the code and making it more explicit and a richer language. Um, Simple example, right? You don't delete an employee, you don't create a new customer, right? You hire an employee and you fire them or you promote them or they quit. Well, if you could create new customer, you'd be rich fast, right? You just keep creating new customers. No, you're onboarding or they signed up or they bought something. Bring that language in there, and your code starts telling the story of what it's doing and why it's doing that. And then when something changes, when you get to this point where your code is very mature, right? Your domain model, your code reflects the model that people have in their heads and even influences it as well, right? Your code and your artifacts, because we think about it that way now. We think of it as different rules instead of nested if blocks. We think of it as a composition of rules, right? That's a much higher level abstraction. That's much more practical. You can start thinking of it as building blocks that you can combine. When you get to that point with your system, um, when a new change comes, um, you don't you're not really changing code anymore. Of course, it's still code. You're still changing it, but you're not going into a deeply nested if clause. You're thinking of it as adding new elements of the same type, or removing things of that type, or reordering the way they are applied. Maybe it's rules that I can reorder, or maybe I can reconfigure the individual rules, right? I say, oh, we have this rule that says, 5% discount in this specific situation. But now we decided we want to make that configurable. So you change that object, that thing, to have a parameter, and now you have a configurable rule that you can recompose, etc. Right? So you get to a point where your code is so expressive that you don't think about it as typing individual statements anymore, but you think of it as recombining these building blocks. That's a very powerful thing. It's somewhat like a domain-specific language, maybe, or whatever. But the point is that you get this benefit, and then when something changes, right, it's just a trivial thing. So I think that's the chief mechanism you should sort of pursue for dealing with ubiquitous language. And then depending on your context, you might need RFCs and be super formal about it, or you could just have like a glossary in a README file, or anything in between, right? I very much like the idea of living documentation, which is where you, as much as possible, you use annotations in your code to document the language. So you have maybe a definition, a definition annotation. You put some explanation there, and then you have something that renders this documentation in readable form for non-programmers. And then there's a great book about it called Living Documentation by Cyril Martrer that sort of expresses these ideas in a domain-driven design mindset as well. But of course, it doesn't apply to all situations. Sometimes you actually really need that long RFC process with different committees looking at it and whatever. But that's the extreme case.
One thing that I'm thinking now when you talk about the domain language is that I've seen another area of design that does a bit of it, which is UX. One thing in UX is you do information architecture and you figure out what are the concepts that you see, let's say, on a page, particularly in more complex screens. And then the relations between those, the actions that you can apply on each of those, and so on. And that's how they figure out how the UX can be improved or can be designed properly. And I was thinking whether you have seen relationships between what is in the interface with what is in the domain
Yeah.
that you model.
I'm sort of aware that they have a lot of concepts that are very similar to what we're doing in domain design. I haven't really dug into UX, so it's not really my area. But a lot of it seems to make sense to me that they're also thinking in models and the mental model of the user and how you communicate that and how they go through process. I think there's a lot of similarity there indeed. Um, there is a risk that if you look too much only at UX, well, the way I would describe it actually is that what is a user interface? Um, it is a bounded context. It is another model. So even if I have, I don't know, let's say you have Twitter, right, the social media app. There is a rich model underlying Twitter, right, with how everything works. But the user sees a different model, right? Even though it's talking about the same things, right? The tweet exists in that underlying backend system, and it exists as a user concept in the user interface, but it means something different, right? It's very much related. It's talking about that same fundamental concept of a tweet, but it's dealing with different properties of that and different. So if you think of a user interface now, a user interface is a model that provides like a facade to the model that is underpinning it, and that difference can be small or great, right? In a simple application, it would be equal almost, or in an application that is aiming at a very expert, a small group of experts, right? So if you build an application for, let's say, day traders, um, your underlying model and the model they interact with will be identical, right? They are actually more expert in day trading than you ever will be. And all you can do is give them enough tools and enough freedom to do whatever they want. When you're building Twitter, your users are totally not domain experts in this massive complex thing that is Twitter now under the hood, right? So that's a typical sort of you need more UX for dealing with a larger audience that is more distant from you than when you're dealing with experts who know the domain better than you do. Uh, but it's a risk that if we focus too much on the user, I think it's great that our industry has sort of figured out, oh, we need to focus on the user and the user journey and all of that. That's absolutely fantastic. But it's not all there is, right? We tend to sort of, we say in DDD, we say the user interface is not the model. It's not the model of the whole thing, right? There's going to be things that are simply under the hood that are not visible, that deliberately should not be visible, but it's usually a richer model in many situations.
Yeah, because I think it has this extra capacity for change, which is very
That too, yeah.
important.
Yeah.
Okay, so let's talk a bit about some of the architectural patterns that came out of domain-driven design. You already mentioned hexagonal architecture, but I wouldn't focus too much on that. I think that is more easy to understand by most people. Just if you start from the domain, then it kind of makes sense.
Yeah.
Let's talk a bit about event sourcing because this is one of the, let's say, stranger ways of doing domain-driven design.
Yeah.
Uh,
Yeah. Uh, it is event sourcing fundamentally is just a you could look at it and say it's just a persistence mechanism, right? Instead of storing the state of something, we store all the changes. It's a change log, right? Um, so that's not new. There's many databases, relational databases that actually work like that under the hood. They store changes. Um, and then doing that in sort of in different domains is also not new, right? Accounting, double bookkeeping, these are ledgers, right? These are long lists of all the events that have happened all the transactions that have happened, right? The bank account is a bunch of transactions. Those are events. So that's not new. I think the main thing that is new in event sourcing is the idea of doing this for everything instead of only for the transactions, for the financial transactions. It's doing it for everything. And the other thing is that this history that we're storing now, this history of events, is that they are the single source of truth for new decisions in that system. So everything, we're not just storing a log, right? Logs are not new either, right? Everybody has logs. But those logs are not really executable, right? They're just sort of capturing things. Event sourcing and event store is a log that we actually use to make next decisions in the system. And then the domain-driven design influence there, which you don't strictly need domain-driven design for event sourcing, but event sourcing grew in that community. It really, in the way it's usually described, it really captures some of that idea. And the basic idea there is that we don't just store changes, but we store the reason for the change in the name, in the type of the event, right? So that name comes from the ubiquitous language. So I could say, for example, order was shipped, and I actually prefer to use was in there. Programmers would say order shipping event or something, or I don't know, or order shipped. I specifically prefer order was shipped because it's how it's the meaning of the event, right? It's not just the idea of the order and the date and the user and etc. It's not just the message itself, but the meaning of the message that's in there. I like that verb in there, that natural, almost like natural language, because it's how we tell stories, right? An event, a domain event is something that happened in the domain that we as a business care about, that we can express as something that happened in the past at a specific point in time, right? Before this event, the order was not shipped yet, and now it is shipped, right? That's the point in time, and that event stores the delta, so all the changes that are relevant at that point in time, right? So if you say customer updated their address, it has the address, it has the customer ID, of course, maybe some timestamps and user IDs, etc. But it doesn't have everything else, right? It doesn't keep well. That's the simple version. There are, of course, exceptions and reasons to do that and patterns, etc. But now that we have that, we can think about that language and what it means, right? Because if the customer changes their address, or one of our employees changes the address, that might have a different meaning in this domain. Very specifically, I've worked in long ago in credit control. When somebody who owes our clients money changes their address, that's different from if one of our credit control employees changes an address. Maybe they do it because they found some new information, or it's a typo or whatever. But if that debtor changes their address 5 times in 1 week, they didn't move to a different house 5 times in 1 week. Of course not. They are trying to escape their creditors, right? So we have that distinction. We can start thinking about, analyzing that, or seeing different patterns in there, or doing fraud detection, or there's a richer language there now. And so event sourcing is sort of capturing all that, right? So it's doing changes as opposed to state. So it's not destructive. You can just keep adding events to your database for every change that happens. If you want to know the state of the system, of course you can reproduce that. You can look at some events or some subset of events, calculate the state, right? Just like your bank account, right? Credited €5, debited €5. I can add up these numbers, and now I'm at 0. I know the balance. And then, of course, that becomes low, but there's technical solutions to that. We have basically caching and etc. Right? So you're not actually recalculating the whole database on every request. but those are the technical aspects. But event sourcing takes this idea of these events. We store the events, the changes, as opposed to the state. We we store the meaning along with them in the name or in the type of the event. And we use these events as or single source of truth for new decisions. So can I can I withdraw €5 from my bank account? Well, let's look at the history. No, because the rule says you cannot overdraw. You cannot go below zero. And I look at my history or my balance that I cashed somewhere, and it says, well, but the single source of truth is that history. I calculate the numbers. I see that if I withdraw €5, I would go -5. That's not allowed. So now that decision is made. And now here's the interesting thing is that this history of events plus this history of changes plus the reason for the change has enormous business value. You don't just know the state of your system, you know why it is that way. That's incredibly powerful. A simple example is like, I know, to say with an e-commerce, a shopping cart, right? If I go on Amazon, I want to buy, I don't know, I want to buy a computer mouse. I add it to my basket, and then I see some suggestions for a nice smartwatch. Oh, I add it to my basket as well. And then I go to checkout, and it's kind of a lot of money. I'll just remove that from my basket again and just buy the mouse, right? So the state of the basket is one mouse. That's still useful. Of course, we're trying to sell that mouse. But what if somebody has a hypothesis at Amazon who says, well, if people put something in their basket and we give them a few weeks and then we show it to them again, or we compare it, maybe even like we look at when are they spending money. Maybe we can have some guesses about when they get their salary, because that's when they spend money. So we need to exactly propose this smartwatch again right when they got their salary, and then there's going to be a higher chance of them buying it. If you have that history, you can start looking in your history if that hypothesis is even true. At this point, you're not building anything, right? You're really just making, we call them projections. You can think of them as queries. You look at that history, you project the information that you need. You can do it all the way back to the beginning of your system. And you have a lot of useful information already that nobody ever built for, nobody designed for that specific feature, but you can just do it, right? Because we know exactly what happened and when it happened and why it happened, right? And this is a simple example, but there's loads of these kind of examples. So that history of events, I would argue, has more business value than a regular database, a relational database, a destructive one where you only have the latest state. Now, of course, we do soft deletes, etc. It's not like we're deleting everything, but now we have a singular mechanism, which is just events happening in chronological order that we can interpret in any way that we like.
And so this is indeed very interesting, because I'm understanding now some of the business values also of event sourcing. So would it be used in applications that are kind of in this area where you also want to do some kind of analysis, business intelligence kind of stuff, or what are the applications?
I think the reason I gave that example is because it's the most easy to explain to business people, right? We will be able to interpret data that we couldn't do before, right? That's the pitch for them. But it turns out that to me, the main benefit dealing with sort of complex systems is that it handles complexity better. It handles changes in complexity better. And I feel that even the event sourcing community hasn't fully grasped this yet, how powerful that is. But what I've noticed is because you're dealing with events, you're naturally more thinking in processes as well, as opposed to entities, right? I see this as two sort of main styles of modeling. You can see the world as structural, as things, things, entities, objects have relations between them, and then stuff happens to them, right? That's sort of the last layer, behavior. Temporal modeling is inside out. You first look at events happening. You say this event happened or this event happened. And then you look at the rules that govern it, right? The behaviors for these events happening. And then you can derive structure from it. You can say, well, if a customer signed on and placed an order, what are the entities I derive from that? Well, I could say there's a customer or there's an order. So we're not thinking of an entity emitting events anymore. We're thinking of events that produce entities. These entities are just interpretations of these events, because I could make any kind of interpretation, right? If you think about it, events are sort of discovered. These are things that happen in our business that we're interested in. So a customer walks into your store and buys something. The next day, a customer walks into your store and buys something. These are events, right? Observable things. And then if I say, well, I care about, so a real world brick and mortar shop thinks of that as two customers. In software, we can say, well, this is actually the same person. We give them an account, so we know that it's the same person. So now I'm saying these two separate events, I connect them, and that gives me some other insight. But that's a choice, right? That's a business choice. So the entities are, you can now choose your entities. And because you have your events, you can choose any entities you like. So I might say, I'm now doing an interpretation where I care about customers, but you could care about product lines and sales within product lines, or you could well, a simple example is if I'm doing a credit control system, I have invoices that are being sent and being paid and being, contested and credit notes being sent and all of that. When I'm trying to get money, I'm not interested in all of that. I'm only interested in unpaid invoices. So I'm now saying that in the context for the credit controller who has to call people and convince them to pay that money, they don't care about that whole model. They care about a different model. So I can, for every sort of context, I can make a model that is very specific to that context. I can say, okay, for my credit controllers, I make a model that only cares about unpaid invoices. As soon as an invoice is paid, I can just remove it from that model. I can delete it. Actually, hard delete that from that database. It's not available in the user interface. It doesn't exist anymore. There is no concept of invoice, only unpaid invoice as the main core concept of that model. And I can do it because I still have the original events. I still have the single source of truth. So if I decide to do something else or have some other role, somebody who has to, and this is also a real example, cash flow predictions, right? We know how many invoices you have. We know of these clients how fast they pay because we have all the events. We know sort of if they pay partial amounts, we know that. So we can actually start predicting your cash flow based on the payment history of your customers and your future and your invoices that you send and all of that stuff, right? And so we are now making many smaller, simpler, more focused models for these specific situations, right? You can think of these as microservices as you like, which is sort of an implementation and deployment pattern, but you can think of it as a standalone model for a very specific problem that uses some of these events as inputs, but that has complete freedom in how to model and structure all of that, right? I don't need to worry about making something that fits for everybody. I can make a database optimized for that kind of problem. If I have, if I want to do, I don't know, suggest friends or followers on Twitter, the best. So maybe the rule is we suggest followers of your, no, we suggest friends of your friends, right? If they're already a friend, we don't suggest them. If they're a friend of a friend of a friend, we don't suggest them. Something like that. That sort of problem, the best way to model that is to do in a graph database, which allows you to do queries like that, queries over nodes and edges. But it often doesn't make sense to use a graph database for everything. But now we have an event store. We can project some of these events into that graph database and only use it for that specific problem of friend suggestions, which is very powerful. So, and that's just one example, right? It's also the whole being able to model processes and how they impact each other, etc. It deals with complexity much better than traditional software does, in my opinion and my experience. There's lots of other things, right? So if you have bugs, for example, right? If you have a bug that accidentally writes wrong values in your let's say in your bank, right? So there's money involved. Sorry, I should have turned off my phone. Okay, so you have a bug that causes wrong values in your database. How do you fix them now? Well, how do you know what they should have been? If you're lucky, you can figure it out, but maybe you don't, right? So it's a problem. If you have all the events, you can look at, where did that bug come into existence? You can, sorry, I'll just turn it off all the way so it doesn't happen anymore. Terribly sorry. You can look at that history and you can reconstruct what it should have been. You fix the bug, of course, but you also reconstruct what it should have been, add corrections to your event store, and now your system is correct again. That's something that is much harder without it. Bitemporal problems, when let's say you want to, you have a decision that is made at a certain point based on the available data at that point. A person needs to make that decision based on the data they have available, and then later new data becomes available. We can redecide, recalculate what the decision should be using that new information, what it was with the old information, whether that person made the right decision, whether they should have made a different decision or would have made a different decision based on the data that they didn't have at that point. You can do that because you have this very temporal database now. And it sounds like a bunch of extreme things, but all these things that I'm describing are some of them are still complex, but they're much easier. I've dealt with long-running processes in life insurance, where the product that they sell, the life insurance product, changes over time. They have, the claims processes, which can take a long time. And then they send experts and they do this and that, and then the rules change while these processes are still ongoing. So you can start modeling if a long-running process is impacted by another process, and depending on when the changes in the one process happens, how they impact the changes in the other process. That becomes very obvious now in with these sort of models and systems. So it's extremely powerful, and I think we haven't started scratching the surface yet of it.
Yeah, so it sounds like it's a more general model that you can then project into various shapes that you need.
Absolutely. Yes. Yes.
Right.
Definitely.
So perhaps you don't use the whole model actually all the time, but you use it for you use projections for certain contexts.
Yes, yes, and you combine it with, typically you combine event sourcing with CQRS, which is more of an architectural style, but it allows you to even more separate and say, this is the model that we only use for writes, for writing new events, for writing changes, for making decisions on making these changes. But we don't need to burden this model with all the other responsibilities, because we can just feed them off the events and make standalone models for that. So you have, complexity is managed much better in smaller, higher focused, single responsibility domain models, and you get much better insight in the actual process. I don't know if we need to go this far, but you can even start putting the changes to your model itself. So your model evolves, right? The changes to that model, you could also model them as events in your event store. Let's say, for example, GDPR was, I think, May 2018. You could model that as a domain event. It's one that only happens once, right? But you say, when this event happens, everything else can react to that. So you can have models that are You could have, for example, we have a way of doing a certain process. We have a model for that in the code. And now we have a new way of doing a certain process, of doing that same process. Because we think in process instead of entities, we can say, well, all the processes that are ongoing, we keep them in the old version. So we have two simultaneous versions of that process, and we just direct, commands to the old version or to the new version. And you can even model a migration from the old version to the new version. This is, for example, useful. Telecom companies do it all the time, right? They have the new version of the product, where you get, this many gigabytes or text messages or whatever included, and then they want to convince you to switch to the other model. But your billing, people who didn't switch still should get the old billing. People who did switch should get the new billing. The minutes should be transferred as well. You can model this as two versions of a process that with a migration and with sort of a routing mechanism in between.
All right, Matthias, this has been absolutely fascinating. I think we could continue and speak for hours about these
Yes,
topics.
absolutely.
You have a lot of interesting knowledge about this, and perhaps we'll do this again. But before we close, what I like to ask you, what would be some general advice for developers who are new to domain-driven design?
Yeah. For starters, don't let me confuse you with all the stuff I was just talking about. No, there's what has changed over the last 10, 15 years is that now there's many, courses and many blog posts and many books. I like the one by Nick Kuhn and Scott Millett, Patterns, Principles, and Practices of Domain-Driven Design. I like Scott Flaskin, Functional Domain Modeling, I think it's the title, or something like that, right? It talks about F#, but ignore that. It's very readable and useful to start with domain-driven design and the sort of reasoning behind it. So there's books, there's webinars, there's courses, there's everything. There's conferences. When we started, there was only DDDX and DDD Europe. Now there's DDD China, DDD Taiwan, Kandinsky in Germany. There's Explore DDD in Denver. Well, meetups have sort of died because of the pandemic. There's still one called Virtual DDD, but hopefully there were like, I don't know, 25 or 30 DDD meetups worldwide. Maybe that will come back, and if not, ping me and I'll help you start one and find people for it. Because that's, for me, that was one of the best ways to learn. I went to a DDD conference, DDDX, back in 2012. I don't know. I met some other people from Belgium who were also there in London. We started talking. We started the meetup, and I learned a lot of sort of meeting with other people and talking about it was extremely valuable. So even if you don't know DDD yet, it's actually a good idea to start a meetup, because then you attract people who can tell you about it, and just start trying some of these things. Right? If you start worrying about the language, right? Some healthy obsession with language, right? What does this mean? Is that the right word for it? Is this the word they're actually using? That's an important question, right? Learn some of these patterns, like value objects, etc. Start using them. If you start doing this kind of stuff, maybe go to the whiteboard or use Miro and draw some pictures. Try to understand, okay, we have these things, we have these, not just the things, but try to put the behaviors on there, put the business rules on there, and draw some lines between them. That will already get you a step further. Don't be scared by the scale of DDD. It's really trying everything from trying to be a sort of holistic approach from small programming patterns to large structure, which makes it hard to access, right? And it is not going to be easy because it is a method or a discipline for dealing with complex systems, right? It's not going to lie to you and say, here are the 5 easy steps to solve all complex problems. That's nonsense, right? So accept that you're not going to learn this in 2 days, But start playing. Find some people in your organization who are also interested in that, right? Find some collaborators, some advocates. Do a lunch session, right? Try to do some event storming, right? Let's think about this problem. What happens? Okay, what is an outcome we're interested in? Oh, the customer buys something. Okay, how do we get there? Well, they need to see these things. They need to pick one. They need to I don't know, pay them money. Let's add some stickies to show that process. What are the rules for it? Oh, they can't do it if this or this happens. Does it branch this process? Well, you know how to visualize a branch, right? That's easy. And before you know it, you're actually doing this sort of valuable domain modeling that turns up a lot of insights. And doing this at the whiteboard, right, with some post-its and some markers, and it's the cheapest thing you can do in software design. After that, it becomes more expensive, right? Coding is much slower and much more expensive. Once you have deployed it, once it's in production, changing it becomes a lot more expensive, right? So if you can figure out a mistake early on at the whiteboard, your cost is, a post-it, a board wiper. If you figure out that mistake 2 years later, the cost is a whole, budget that needs to be allocated for it. So just start trying to do some of that with some of the people in your environment. Go talk to some domain experts and ask them questions about the language. Try to not sort of they will try to make it simple for you, right? They will say, oh, but don't worry about that. That's very complex. Or they might not even know themselves, right? And they will say, "Oh yeah, but that's very this sort of movement of sort of that's very complex. We'll talk about that some other time." That might mean that I don't really know, um, or I think you wouldn't understand, or you don't need to understand. But they're wrong about that very often, right? You do need to understand it to build good software. Or they might say, "Oh, but we've already written that in the requirements." Sure, but that's not enough. You need to understand it and turn it into models. Right. If you do some of that, right, you're already making great amount of process. You don't have to understand the jargon of DDD. There's a lot of that. That's normal because it's finding patterns and abstractions over complex concepts. Don't worry too much about that. Just start doing some of it. Start doing it first before you will build sort of an intuition for it, and then when you read more things or you go to courses or you go to DDD Europe, a lot of it will make sense easier because you've tried it yourself, right? You got some experience with it.
All right, Matthias, thank you so much for these insights. Where can people find you?
My blog is at verraes.net, so I write about this kind of thing. And the conference, of course, is ddeurope.com. The next edition is in June in Amsterdam, so you can meet me there and have a chat. And it's a friendly community, and we have DDD Foundations, which is more of a not just introductory, but more. It's a sub conference that talks about the established concepts in DDD, and then there's the main conference, which sort of tries to look outwards and expand it and look at new ideas. So maybe you find something in there for that fits you. We have workshops, etc. So those are all good places to start looking.
All right, that sounds very good. Thank you so much for joining me today and for sharing all these insights.
Thanks for having me.
So you've heard everything about starting with domain-driven design, about thinking in this way of modeling and designing complex software. And I hope you find this interesting. I think we've learned a few things here. And as you know, I'm a big believer in the importance of words in software development and in understanding the words that you use and in searching them. And this is, to me, it's an extension of language fundamentally. A recognition that language is a big part actually of architecture and of modeling in software. So with this being said, I'd like to thank you so much for watching this. We have to pay our dues to the YouTube algorithm, so please like, share, subscribe, tell other people, leave us a comment. ask questions. If you have any ideas for other topics that might be interesting to you or other things that we can do, let us know and we'll make sure to do some of those. Thank you so much for watching, and until next time, remember to think, design, and work smart.